started. Make sure. That things are working. Seems like it is. It is for the most part. Yeah, good enough. Some music. We'll do something chilled. I usually do house music, but maybe I'll take it more chill, doing peaceful piano. Okay, wait a little for a few people to join. Let's see. Okay. So I'll just want to solve it. And I want to show off our new feature, which I feel like is pretty cool. So here's the regular question. We're going to be trying to solve this today. I mean, it says it's easy, so probably, hopefully, who knows, shouldn't take too long. Basically asking us to implement Nostrov's accelerated gradient optimizer. And so updating a single step. Function velocity at the input, return updated parameters value, new velocity. New function, choose look ahead, approach, configure gradients, should handle both scalar and array inputs. Sounds nice. Let's actually see what that means. Just take a second to get properly set up. My headphones stop working, but I pick up something else. Okay. Nag for short. I want to show off the thing. I keep on thinking, oh, cool, but the new thing is this. It's the AI Tutor. You can ask it about the questions. It won't necessarily write you the code like every other LLM, and obviously I didn't make my own LLM. It's, some LLMs in the background, some APIs in the background. But I think it works nicely, and I think it's helpful. I'm assuming a lot of people already are using LLMs while solving these questions, so I don't think there's an issue with it. I just don't want people using it and generating solutions for them. But I mean, they can still obviously do that. But I could basically ask, explain this question simply. Zoom in for you guys. Okay. I don't have scrolling because I'm zooming into this. So just trying to get a good zoom. Negative terms. You're like a small ball rolling down a hill. Regular momentum. Okay, we know regular momentum. I'll try and do a little more teaching this video. I usually don't do much teaching. So I'm just like, I just want to learn myself, but I guess a really good way of learning is actually trying to teach people and see what you know and what you don't. So regular gradient descent, you go 1, 2, and we're going down this hill, and eventually we'll get to the bottom. Momentum gives a certain weighting to the last movement as well. Usually something around pretty high, like 0.9 or higher than that. So the next movement would not only be related to the current gradient, so the current slope. So it would also be related to the last slope. Let me know if that makes sense for you guys. Yeah, so basically he does this so there's some momentum, so theoretically a useful case would be, this, go back up, and the ball's, let's say, here, and it's making its way down. If we don't have momentum, we're just doing it based on the gradient, we might like get stuck here. But if we're looking at the last step, like it has some velocity from the last step. If it sees like, oh, this is a big movement, it'll still make big steps. Obviously, it will slow down, but it will make big steps. And that, like, momentum. So if you think about a ball rolling down a hill, if this was actually like if I were rolling down this hill, it'd be like, woo. It could be, it would continue. So it takes the momentum from the previous steps and applies it. I think that's a good definition of momentum. Let me know if anyone disagrees. So that's regular momentum. Okay, nag. Nag, the ball first peeks ahead where it'll roll using its current speed, checks the slope there, then decides how to update the speed and position. So this isn't making much sense to me, but let's continue reading and see. See what this is. Look ahead. Then it's 3 steps. Peek ahead. Look ahead equals current position minus momentum times current velocity. Okay. So I don't really. Understand what this is. What is peek ahead? Let's see. My peek ahead. Regular momentum computes gradients. Position data -1 and updates. Nag says before I compute the gradient, let me temporarily jump ahead where I think I'll go next and compute the gradient there. Okay. This gives a more accurate slope of actual path they're taking. So it's trying to make a small, my understanding is trying to make a small prediction of where you're going to go next, check that gradient out, and I guess make a little edit based on that. Okay, so the look ahead formula. You have your current position. And we have the momentum step. Okay. Where we have 0.9, it's fine. I mean, it's how much to actually care about the momentum is that 0.9. And you have v -1 current velocity. Okay. Subtract because velocity points downhill, negative gradient direction. Okay. Sort of understand that, not fully, but we'll try to understand it more. Let's see if I can do this. I don't know if this will actually work. We'll see if that'll work. So theoretically, probably should give people an option if they want to generate a question. I'm gonna run into this. Okay, just want to show it off simple. cast gradient descents. Okay, let's try this again. I know we're making good progress in my, actually using it. But let me see. Hoping this works. Oh yay! It's working! So, the cool thing about this, it will occasionally, as you see, we have to work it out a little. Probably should give people an option just if you want to use the tool. But the LM has the ability to generate, questions. Oh, never mind. Again, this is pretty beta. Not use it. Let's try it again. I'm assuming it's timing out. It's probably timing out. I thought I dealt with this issue. But it happens. I mean, this is, it's a more of a beta feature. Yeah, okay, that's not gonna work. But we still have the main functionality working. We still need to work out some of the kinks with the problem generation within the AI Tutor, but the main functionality works. And also, if I try and ask it the solution, you want to know some keywords will block the. Let's say just implement this. It won't actually give me the code, which I feel like is I mean, I don't think people actually need, I don't think people, like, if the LLM's giving you the code, then you're not actually learning anything. At least here, you have the power of an LLM. It can explain things nicely, it can explain things differently, you can ask follow-up questions and all that jazz. Yeah, I use the term jazz, I don't know why. But it has the benefit of not actually giving you the results. And also I could say, like, I don't remember the NumPy, function name, so I could ask here. I wonder if this will. I could theoretically ask about generating random numbers. Like, okay, cool. I don't need to open a new page, look at the documentation, or go to ChatGPT as much. I'm sure there still are cases to go to ChatGPT. It's probably, or Claude, or whatever you're using. Very disappointed about the whatever though. I had it working before. Now I'm annoyed. Where was it working? Work, but we're basically, ideally, in an ideal situation. Let's see if this one will work. Issue might be, I think let's see if this works now. We can finish that sentence. Come on, you know you want to. It's actually working. Okay. It's right now the generation is pretty buggy, but when it works, it's pretty cool. Calculate the mean of a list. So let's solve this quickly, and then we'll go back to the daily question. Write a function that calculates the mean average of a list of numbers. This mean is the sum of all elements divided by the number of elements. Okay, we know what the mean is. Calculate mean. List of numbers. So theoretically, let's do it the old-fashioned way. Turn sum of numbers divided by length of numbers. But we'll make a mistake on purpose. And we will add +1 to it. It's going to run through some test cases. Just thinking about it. Let's see. How many test cases did you generate in this? Okay. Yeah, again, it's in beta mode, I'd say, right now. It's something fun that you can play around with, and the generate questions might work sometimes, might not work sometimes. I think the main functionality should work. But now I can say, okay, obviously, I'm stuck somewhere here, and I could show learn section and try to read more about it here, just generally. But if I have, a specific bug, I can just say, ask AI for help. I'm convinced it looks ugly, but it will. Let's run that again. Yeah, we're still working out some bugs. And I wish it was more, acting a little nicer during the live stream, but, Is there any a question for you? No, I don't want this. Also, I guess I have to add a stop button. I wonder which kind of question it'll generate now, though. Yeah, okay. You see what the dream is. And we're going to work on that and make it, I guess, better before we actually fully release it. I mean, you can play around with it on the site. It's probably useful for what I was doing in the beginning with it, and we'll continue with that. Let's clear this and start again. Step-by-step plan to solve the problem. I mean, I feel like some people might be annoyed by this. Maybe not. I'm just making this up. I could imagine people being annoyed by, like, oh no, there should be no LLMs. Why help people cheat or something like that. And in my mind, I don't consider using an LLM cheating necessarily. I mean, if you're using it for the whole question, it's a little whatever. But if it's just explaining a topic to you nicely, I think that's fine. It's my opinion on the matter, at least. Break down that. Okay. My given velocity. That makes my life a lot easier. So I have to compute the look ahead. So this is gradient look ahead. Oh. Okay, so I guess before we do anything, we get the look ahead, which is our current theta minus the velocity. Given the velocity, curious how they compute the velocity, but okay. Update the velocity. Okay. So you have your new velocity equals your old velocity times the same gamma as before, plus the learning rate times the Jacobian times of the look ahead. So this is, let me try to understand this. So this, we know, this is the old velocity, given the old velocity. I guess this is assuming we made this look ahead, you know, we went here. What would the gradient be? So let's try and understand. Let's try and draw some pictures. So we have our current position, we'll say it's that, and we have our little look ahead. And our look ahead, so put that big of a look ahead, basically says, so how we compute the look ahead, we said it was current velocity, v, or theta minus velocity plus velocity? No, theta minus velocity times that gamma, so it's 0.9, sorry. And this is how we compute this, and currently we're at theta. I'm just going to try to do a better job explaining. I said that before, but yeah. So let me know if something's not clear so I can improve my explaining. So we have theta, and this is the look ahead. Okay. Okay, so that's how to get the gradient. Okay, so now we're going to update v, which is the velocity. So we have the old velocity, which is just given to us, plus the theoretical move of the Jacobian. Okay, so it's saying if this was our new position, so if this was our new position, I can't draw that. Okay. So it's saying given, let's say we were here, let's take the partial derivative as if we were here. Yeah, and that's that value right there, times the learning rate. Okay, update parameters. I guess this is the slope at theta. So it's not necessarily this point, it's the, you know, it's the slope here. So you take that slope and you add it to your old slope. So it's making some sort of momentum. So you have this slope, you have this slope. Adding those two things together to make some sort of momentum calculation. And then you subtract the velocity minus the current parameter. I'd imagine the issue with this is, I'm imagining this is a little computationally expensive. Maybe I'm wrong. Why is... if I could ask general questions to it. yeah, I was assuming this would be a big portion of it. But let's try and solve this. I think we have a good understanding. We'll try to do it. You know, we'll try to do it without the learn section open. See how much we actually remembered. Okay. Parameters and velocity I need to return. The parameters, current parameter values. Okay. So first we compute the look ahead. And the look ahead was, I'm assuming parameters is the same thing as data. Parameter minus, okay, momentum is the y, momentum times the current velocity. Okay, so this is ahead equals this. Parameter minus momentum times velocity. Also, let me know if you find the tutor helpful at all. Zooming in is trying to be nice to the people watching, but the website doesn't drive super well with zooming in. Usually it drives well here. Okay. I don't know if that helped at all. So we have our look ahead. And I'm pretty sure we're given gradient function. Let's see if I remember. So we have theta. We're basically trying to compute velocity. I think we have, we call it this term grad, and that's velocity plus the learning rate. Learning rate times the look ahead. No, the gradient of the look ahead. Because the velocity, I guess, is giving us that slope, I guess. Current momentum. Okay, it's a current momentum coefficient. So just telling us what was the previous slope, what was the slant of the previous step. Let's see. Velocity plus learning rate times gradient function. So we get the gradient of the current location of things, or our guess at what it would be. And that would be grad. What would this be for velocity? Would this be our new velocity? No. I guess so, yes, it's the previous term. And I guess we're updating our parameters. Parameters equals parameters minus learning rate? Yeah, minus velocity. Pretty sure this is correct, but I might have made a mistake somewhere. But let's see. Error 429. It's not helpful at all. Okay. These are 429 error. Why am I getting that? Seems to sometimes work. Make sure the site's still working. Okay, let's see. Utilization is an error. Velocity updates. Velocity equals momentum times velocity plus running rate times gradient of the look ahead. Oh. Momentum times velocity. Did this say? I think that didn't say that. Oh. Okay, it did. I just didn't realize. Yeah. So it is current. I don't like how it's called momentum, but it spooked me a little. Let's see if that's any better. Oh, nice. Cool. But also, I mean, theoretically, this could interact with your code. I wonder if this is a potential debugging. Parameter updates. Okay. You know, 90% of the way there. Maybe we need to add more test questions. Okay. Okay, but yeah, pretty easy. I'm a little frustrated that the question generator, I think I know what's the issue with it currently. But let's continue solving. That was a pretty easy question. We added a bunch of new questions. I still want to complete. What is it? Single neuron with back operation. I did. RNN with back op. No, I didn't want to do that. I want to do the lab question because we have. Where is it? This lab question. I want to do it using CNN still. It's still a goal of mine. We currently also don't have the AI Tutor as part of the labs, just for the problems. We'll probably add a version for the labs as well eventually. First, we have to fix up a few bugs with it. What was it called? Elastic nets. Single neuron with back prop. No, I don't want it. I want it multiple neurons with back prop. We did this one last time. And run the basic auto read operation. Okay. Yeah, this is what I wanted. Yeah, I mean, Andrew Karpathy was a big influence on, I guess, the site in general, just his idea for, yeah, creating this micrograd, and this question was one of the questions I wanted to make a lot because of it. I still constantly forget it, though. But let's go through it. I don't think I need to touch this. Add. forward pass. Wonder. I guess I'm wondering right now, do I do a backward pass within the addition, a function of its own, or do I do everything in backward? What's this? Do a forward pass. Different function. I don't know if that made so much sense. I don't know. Okay, I mean, I don't know. No, maybe it'll work. I don't know what kind of questions. I mean, I guess a question right here would be useful. Come on. I believe it could work. Yeah. This doesn't seem to be working all the time. Let's go with this. Okay. I think it's also good because I guess there's a lot of small nuances to this question, but and these questions in general, but you don't need to keep like stored memory. I think it's things you know, but you might need to look up a few things. Okay. So theoretically, we're doing turn self.data, so it's actual value, plus other data. That should be our addition. Let's read a bit more about it. Create a new value, data equals self.data plus this. Track operating store underscore child self. Oops. That's sort of okay. That's the thing I always forget about the back propagation. I know it's just like I guess a simple-ish algorithm. I do always forget it. What does the addition of gradients? So if you take the gradients, I mean, I guess it just makes it 1. Okay. So either way, it's 1. Let's see. Let's go data equals this. Child equals it equals both. Let's see. Oh, yeah, it's a triple. I was like, how should we store these? Self, comma, other. Operation equals plus. Okay, like this. Yeah, I always forget how that does work again. Okay. Let's try something, and if it fails, it fails. So we want something like this. Flip that backward. And it can just be one. Let's save this. And I think I should be able to ask. I should ask here if my current implementation's going well. I mean, I feel like this, in my mind, is the future of learning. Like, if something like, in an ideal world, anyone can solve any question they want. It might take a complete beginner a lot longer to solve than an expert, but I think anyone should be able to solve a hard question if they really put the time and effort into it. And yeah, I mean, I guess that's it. It's a simple thing that I want. Okay. Yeah, like this is such a nice way to learn right here. It's like, hey, you know, the child that the op seem good, but not being stored. Your value in it expects. So let's say no value in it. I mean, it's very annoying that the question generation portion of this is not working, because I feel like that was the coolest bit. That was the, you know, I didn't understand the ad, then it'll generate a question just for the ad and give you learn sections and details, but this is still, I think, pretty useful. Paid users get, I think, 100 questions, 100, you know, asks. Free users get 20 a day, or 20 every 12 hours, I believe it is. And then paid users 100 every 12 hours. But yeah, I think it's pretty cool. Let's continue down this rabbit hole. Okay. Create a new value. So we need a new value. Confused by. Let's continue reading. Don't mutilate self, so don't touch self, which be a new one. Then we have Treasure has previous set child. Okay, yeah, so we have underscore prev equals underscore child. Let's see. I didn't want to make. Yeah, I gotta work on this whole generate question feature. It seems more like a bug right now. It's funny because I feel like a lot of people are like, oh, bug or feature. Usually when something's a bug, but it's really secretly a feature. Here, let's see. Okay, there we go. One of these days we're gonna get. By one of these days, I mean I made this today, or I released this today, and I was expecting a lot of bugs. Let's see. So self-grad. One times output. It should be plus equals. Okay, ingredient self.grad plus equals 1 times outgrad. This equals lambda. Okay. We're just gonna copy this. See if we're getting any closer. Probably should read this a bit more thoroughly. It would have been nicer if I could, it's fine. This is on the wrong track. Thanks for letting me down. Thanks for letting me down softly. Okay. I think I'll continue to solve this. I'm just I'll be right back. We'll continue reading this, but I think it's in the meantime. I don't think this is gonna work because I mean it hasn't been working. It worked once, and I think we just got lucky. I don't know what's causing us to get lucky, and I need to fix this issue. But while I run, I'll leave you guys with this in case it works. Man, I was really hoping it would actually work. I really want to fix that. Yeah, that was the appeal of this. In my mind, it was the appeal of this tool. Or one of the appeals. I think it's still very useful to have this. Because, I mean, I could read the learn section. But I guess the learn section is stagnant and can't really ask questions to it, and we can't be like, oh, how's my code looking? Because right now you can start building it and you run it and think there's a bug somewhere and you have to go find it. Here, you could have a very iterative process of just solving the question. I think it's pretty cool. Let's continue. Where were we? Okay, so we have, let's do some drawing. Let's say this is our big autograd. This is a big autograd function, and its job is, I guess, to produce, the output is something called a value. And in a lot of cases, a tensor or an array or whatever else, but in our case, it's value. And the value is made up of two main things. It's made up of data, which is a number, ints or floats, or what other things it's data. I think it's int or float, but we'll say because I'm probably missing something. And it also contains a gradient. Or I guess it's not outputting this, it's sort of within the autograd, there are values. I'd say values are more inputs into our autograd. For example, we could say A plus B squared. Then I guess we want the autograd to basically do the derivative in respect to A and then in respect to B, or in respect to A or respect to B. If we do it in respect to B, the partial derivative in respect to B basically becomes 2 times B. So theoretically, if we put this into our autograder, we would want, and if someone actually doesn't know this, go watch the micrograd video by Andrew Gavaldia. I feel like it will explain this a lot better. Like, this is me learning / teaching. I feel like it's gonna be flawed, and I'm gonna be understanding along with you guys. So if you enjoy it, that's helpful. I mean, more power to you. But if you really want to try to understand this and get a good, well thought out explanation of every detail, I'd say perfectly, or as close to perfect as you could get, go watch Andrew Karpathy's videos. But now that I tried to convince you to leave, if you're still here, we will continue. So we have our autograd. Our ideal situation is we have some function, and we get the gradients on the outside. So then we need to be able to, I guess, deal with plus, multiplication, subtraction, and all that fun stuff. So let's continue. So let's talk about, within our autograph, we have something called, so we're trying to recreate the meaning of addition, because the addition should not only add up the values, it can also affect the backward pass. So let's say we have our add. In our add, I guess what's the main inputs? Takes in two values. Takes in two values. Call it A, B. And a value, we sort of stated before, is made up of data, which is a number, and grad, which is perfectly awesome. I guess the value is not only data and grad, it also has children and things like that, but let's try to figure out one thing at a time. Let's see. So we have A, we have B. Those go into our new add, and it will take A dot data plus B dot data. And that will be one component, or I guess we'll have C. C equals this. So we have a new variable, C equals this, and C is a value as well, meaning it has the data and has a grad. So now we know how to compute the plus for C. We need to know how to compute C dot grad. See if I'm getting this right. So if we take this in regards to A, this, I guess I'm a little confused about right now, because if you take the derivative of this in regards to A, then A would become 1. That's it. And if I take in regards to B, then this becomes 1. So I'm a little confused on how we do the gradient in regards to, like, what does this actually mean? Let's go here. Let's see. Okay, we have A plus B, we know that. The local gradients are simple, yes. So this is what we were saying. So this is, I understand. So this is the gradient of some term s in regards to a. So if we take the derivative of this in regards to a, this becomes 1, this becomes 0, and same thing for b. Remember chain rule backpropagation. Let's see. So if the output of s is incoming, gradients s dot grad. So we know this also has some gradients. Okay. Let's continue reading this. I'm skipping ahead. Okay, common pitfalls in the approach. Don't set the gradient inside add directly. Forward pass creates new value, okay, which is this s. It stores stores who the parents were in previous. Backward pass later traverses the graph and pushes the gradients. Forward compute data stash. Here's a backward lambda that leads to final. And now you're gonna have to get into topo sorting later. I think that's the ordering in which you do gradient descent. Do the autograd. But we'll get into that later. Okay. When this node gets its grad, how do I push into partners twist? If a plus b gets gradient 2, both a and b should become 2. Does the gradient just become 2? I'm so confused by this. And I feel like it's simple, I'm just not getting it. Let's see. Gradient flow for addition. Forward. Oh, that looks a lot nicer than what I did. Whatever. Mine's technically correct too. Just because theirs is nicer doesn't mean you should be mean to me. Okay. Okay, store a backward lambda on out. Will they just mean have it waiting? Oh. backward. Okay. Review when I'm done. It's the gradients. See? And I know if I was using ChatGPT right now, I would just ask for how do I do this? And the amount of learning I would do from that would be significantly less. Let's see. Let's go. Let's see. If we did it. Integrate definition. Let's try to understand this. Okay. Converts everything to a value. That's nice. Or converts other into the value, so you could take something that is a value and add it to something that's not. Cool to use. Okay, we did this. More or less. Def.backward. This is the issue we're having. So, let's see. Oh, it does have a none there. Okay. So we're supposed to make a function. It deals with it. So function that deals with it. And it takes the current gradient and adds. So for the current value, I guess my question is out.grad. I guess out.grad. Oh, okay. So out.grad will equal 1. It's the gradient of out. I was setting it somewhere, I would imagine. Oh, I mean, okay. I know I said like 20 times, but I think I got it. So grad is set to 0. So, like we were saying before, the gradient of the gradient in terms of a, you basically make this 0 and this would become 1. So, now I'm a little confused though, because this theoretically the self.grad value self has a gradient 0 starting out, and we're adding out.grad, which would also have a value of 0. But I guess in terms of if we're back propagating something, if we're doing something a lot of times, like if we do, right, so if we're doing back propagation, then there should actually be the self.grad doesn't always equal 0, and out.grad doesn't always equal 0, so it's important to know that. Fine. Self.grad underscore grad. No, just a grad plus equals other grad self dot other dot grad plus equals self dot grad. And then it's updating. I guess then we know how this new backward function. We'll draw it in a second. In itself was a value. It's out. Out we used old val. Old val dots square. It's actually a function that we're no. I don't know the difference if it's in this or it's in this. I remember Angelo Buffet saying there was a difference, but it's currently lost on me. Okay. Let's see. Let's see if this is. Let me save this. Now is my. Boy. Only one thing to do in a time like this. You need to know, am I doing something wrong? Or is the AI thing doing something wrong? So we will take Andrew Karpathy's code. Because we know that's true. And we will ask it again. Because now we can see, is it okay, I guess I will never sort of saying things I could improve. Potential pitfalls to double check. Okay. Doesn't seem like there's any big issues. I'm assuming there's no issues, but I just want to see if that was correct. Okay, now let's try and understand. I guess we have to sort of see the whole picture to understand how backward really works. But theoretically, okay. I guess we need to figure out how backward works in order to understand, I guess, this. Like, why are we doing it like this? It's a little hard to understand, but if we had backward, it would be a lot easier to understand. It's either okay. It's either 1 or 0, if, depending on what x is, the gradient here. I'm sorry, I'm a little sleepy. Okay. I'll stop here. Save my code. Save initial properties code. I'm gonna hopefully come back here and try and solve it. Next time I'll hopefully have the question generator aspect of the AI tutor working, because I feel like that's, in my mind, a really cool feature. Basically, the AI tutor can choose to create the question for you if it thinks you need it to help you understand the topic. It's currently not really working, but I think even just having this information be able to ask follow-up questions and clarifications should really help people solve questions, solve any question you want, because that's the goal. I want you to look at a hard question and be like, oh, I can solve that. It might take me an hour, 2 hours, whatever it is, but I know the ability to solve something with enough time is pretty amazing. And yes, obviously, you could just look it up on ChatGPT and you get the correct answer, and congratulations, you did nothing. I mean, copied and pasted, so you learned that skill well. But I feel like, I guess here's the feature I'm proposing is something that's like, hey, I do less than ChatGPT. I don't help you as much. And I think that's a really good thing. And hopefully I'll have the problems fixed up soon enough. Thank you guys for joining.